Okay, so in this video, we're going to explore the sine and cosine graphs. And so what we're going to be looking at is, what is the graph of y equals the sine of x, where x is going to be in radians. And this is the big reason why we start studying radians, is because it makes this way easier. So to do this, the first thing we're going to do, now note, this is not the graph itself. This is just going to be to help us find the t-chart that we need to graph y equals sine of x. And so what we're going to do is we're going to look at the unit circle. And if you remember, on the unit circle, we had certain points that we knew really well. Those are at 0, pi over 2, pi, and 3 pi over 2. And remember, sine of all these is just the y coordinate as you go around the circle. And so this is 1, 0. This is 0, 1. This is negative 1, 0. This is 0, negative 1. And then we also know when we do pi over 6, right? This is, when you do pi over 6, that's 30 degrees. And so the coordinates here are, if you remember, 1/2 and root 3 over 2. Or actually, that's backwards. Root 3 over 2 and 1/2. The y coordinate here that cuts a short leg, we got a unit circle, so our radius or hypotenuse is 1, and so the y coordinate is half of that. And then at pi over 6, or pi over 3, which is 2 pi over 6 times 2, that's a 60 degrees, and so these two are just reversed. X value is 1/2, y value is root 3 over 2. And if you notice, as you go around, this one, it's the same except for you change the sign of the x, right? For 2 pi over 6. This one is for 5 pi over 6 is just going to be changing the those around. Again, the y being, x being negative, the y being positive. Down here, and I'm just going around to the pi over 6's here, it's going to be the same thing, except now they're both going to be negative. Negative root 3 over 2, negative 1/2. Negative 1/2, negative root 3 over 2. And then for these 2 points, the x is going to be positive, but the y negative. And you can see that there's just some really nice symmetry that's happening. The x is positive, y is negative. As you go all the way around for pi over 6, 2 pi over 6, 4 pi over 6, 5 pi over 6, 7 pi over 6, 9 pi or 8 pi over 6, or 4 pi over 3, all the way around, it works out really nicely. And then we can also look at these right here, which are our pi over 4s. And remember, those, because it's 45, 45, are just root 2 over 2. And they're the same all the way around, except that you just change the signs as you get into the different quadrants. So if I want to do sine of 6, y equals sine x, then what I can do is make a t-chart. We're going to make a really large t-chart so you can really understand what's happening here. And on our really large t-chart, what we'll do is we'll just do the pi over 6's. We're going to ignore the pi over 4's. We'll point them out on the graph as we go along. But just to make things easier, we're just going to do pi over 6. And so we're going to go 0, pi over 6, 2 pi over 6, which is pi over 3, right? 3 pi over 6, which is pi over 2. And so there should be pi over 3 here. Sorry, not 2 pi over 3. And then 2 pi over 3. And then 5 pi over 6. Again, we're just going by, and then pi. We're just going to keep going, making this a really big t-chart. 7 pi over 6. 8 pi over 6, which is 4 pi over 3. I don't know why I'm making those longer each time. And then that gets you to 9 pi over 6, which is 3 pi over 2. And then all we're doing here is we get 10 pi over 6, which is 5 pi over 3. And then finally 11 pi over 6. and then we get to 2 pi, which is 360 degrees or all the way around the circle. Well, now that I've done my unit circle here, filling all these in for the sine function is just doing it for, actually, let's just do it for, we'll do it for sine first. We'll make kind of 2 columns here. We'll call this sine of x. That's the sine one, and then we're going to do cosine as well. We'll come back to that in a second rather than make a brand new chart for all this. So for sine of x, it's just the y coordinate, and so it's going to be 1/2 root 3 over 2, or actually this is, sorry, we need to start at 0. So it's going to be the y coordinate 0, then 1/2, then root 3 over 2, then 1, right? We're right here, pi over 2. Notice how the y value is staying positive in the second quadrant. We're now in the second quadrant, so it's going to be root 3 over 2, 1/2, and back to 0. Notice the symmetry that's forming there. It kind of looks like a parabola, which the graph of a sine looks like a bunch of parabolas connected together, and so it's got a similar symmetry that a parabola has. Then when I get to 7 pi over 6, everything's the same, except now we're in quadrant 3, and so our y values become negative, and so it's going to be negative 1/2, negative root 3 over 2. At 3 pi over 2, we get a negative 1. And then 5 pi over 3, you get negative root 3 over 2. 11 pi over 6, you get negative 1/2, and then you're back to 0. And what happens is, after that, you just start back over in your circle, and it is it has this nice symmetry. So what does the graph of this look like? Well, we're going to graph this. We're just going to look in the first quadrant right now. When we graph it, we're going to let this be 1, and this be negative 1. And then we'll do this in terms of pi over 2's. And so pi over 2, pi, 3 pi over 2, and then 2 pi. And so each of these would be your pi's, these break into thirds to give you the pi over 6's. So the first one is 0, 0. Notice sine always starts at the origin, right? The value at 0 for sine is always 0. Important to remember that. That's really going to help you along the way. Pi over 6 is 1/2, so it's halfway up. Pi over 3 is root 3 over 2. Root 3 over 2, root 3 is about 1.7, so it's about 0.85. So it's somewhere there, almost to 1. And then you get to, at pi over 2, it's 1. Then it comes back down a little bit. And then at 5 pi over 3, it goes back to 1/2 there. And then at pi, it's back to 0. And then here, you're at negative 1/2. 7 pi over 6, right? We're right here. It's negative 1/2. And then it's, just barely negative 0.85 or so, whatever the root 3 over 2 is. And then it's negative 1 at 3 pi over 2. And then you can start seeing this symmetry that develops along the way as we're going. And so a sine graph ends up looking like this. It has this nice wave that happens. And if you were to keep graphing points, you would recognize that it's going to do the exact same thing, right? It's just going to keep repeating itself. And so it has this nice length to it. And remember, we talked in 11.3 about period of a function, right? A period of a function is the length where it repeats itself. Well, the general sine function repeats itself every 2 pi. The period of the function is 2 pi. The other thing to notice is it has a maximum value and a minimum value at 1 and negative 1. And so it's those two. Okay, we call that the amplitude, and that is the distance from what we call the midline. This is the midline of the graph, and it's the distance up and down from those is called the amplitude. And so the midline is halfway between the minimum and maximum value. And then the amplitude is the distance between those, between the midline and max min. Okay, now this is our sine graph. And so if you notice, it has these very specific things in common. It's got a period of 2 pi. It starts at 0, 0. It goes up 1, and then it goes down to -1, then up to 1, then down to -1, and up to 1. And so it has this repeating up and down pattern to it. It is. If you notice also, this is an even graph, right? Because it is... an odd graph because it's an odd function because it's got symmetry about the origin. All right, and then the other one is cosine. Well, if you do cosine, notice that all we've got to do is the x values here. And so first off, it starts at 1. So we look at this, it starts at 1 instead of 0, because the cosine of 0 degrees is 1, because the x-coordinate's 1. And then it goes, the first thing it gets to is √3/2. Then 1/2, and then 0, right? At pi/2, the x value is 0. And so it has the same symmetry, it's just shifted down a little bit. Now notice that we get into the negatives immediately for the cosine. And so it's going to be -1/2, then -√3/2, and then -1, and then -√3/2, -1/2, and I skipped one there. So hopefully you're seeing how the symmetry in this graph, and then we get 0 at 3 pi/2, and then but we're back to positives for the x, 1/2, √3/2, and then finally back to 1. So when we graph the cosine function, what it's going to look like, we have the same thing that we did there, where we're going to call this 1, and down here -1, and then we're going to go by pi/2s. And so you're going to, and then you're going to have these every pi/6 is what we're actually going to look at. And so it starts, instead of starting at 0, 0 like the sine does, it starts up here at 0, 1. And then notice that the first one closest to it is always the √3/2. And then you get to your 1/2, right? Pi/3, cosine of pi/3 is just 1/2. And then at pi/2 it's 0. And you start to see the same symmetry that we saw in the sine. It's just shifted over. And it turns out that sine and cosine are just shifts of each other when you do your graphs, which is an important, interesting fact about them. And so your cosine graph, one period of it, looks like this. It looks exactly like the sine function, except it starts at 1, 0 instead of zeros, or 0, 1 instead of 0, 0. And so you're going to go like this, and then from there. All right, so again, you've got all the same things. You've got a midline that is in the middle of it. You've got the amplitude, which is the distance from the midline to the max and min, and so on and so forth. So what we're gonna continue to do then is we're gonna explore these where you start adding some stuff in. And so if you think about the y equals sine of x, there could be something multiplied by it. There could be something multiplied by the x inside the function, sine of 4x, sine of 2x, and then there could be something added over here. And so what becomes important for us in graphing these is what effect does changing these? And so we'll explore that in a later video. But that's going to be an important thing, is what happens when we multiply the function by something, what happens when we multiply what's inside by something, what happens when you multiply the outside by something.